So I'm going to summarize all the trig identities, and then we're going to work on verifying identities. So my suggestion is that you get a blank sheet of paper and make the most beautiful, organized master sheet of identities that you can. This is actually a really good study strategy to help your brain start processing, because there's a lot of identities. So I'm just going to throw these up on the screen: reciprocal identities, quotient identities. You can just pause if you need to write them down. Pythagorean identities, even odd identities. And if, by the way, if there's some of these that you don't know how to use, I have a video on like basically all of these sets, so you can go back and check out any of my videos. Cosine of a difference and sum, the cofunction identities, sine of a sum, sine of a difference, tangent of a sum, tangent of a difference, double angle identities, sum to product identities, product to sum identities, half angle identities. Okay, so like I said, the whole idea here is we're going to use all of those identities that I just listed to verify these bad boys right here. All right, so a couple of things about this. This really kind of turns into the Wild West because you've got so many identities. If you really are trying to understand this, I'm going to have to, remind you math is not a spectator sport, and I'm really going to have to challenge you to pause and try these out, get stuck. Some of these, at least one of these, I think is super, super hard, actually. Maybe more to you. If you just sit here and watch the explanation, you are not going to get as much out of this video as if you sit down and you struggle and you figure out where you got stuck, and then you watch the explanation and you get that light bulb moment. I can't make the light bulb moment happen unless you've had a moment to think about these. So I'm really passionate about pushing you on working out the identities, because identities were really hard for me when I took trig. I thought I was terrible at them, and I wish that a math teacher had told me that identities require patience, practice, creativity, and deep breaths. They're not something that you're necessarily always going to be good at right away. Something that's going to happen when we go through some of these identities, this creativity thing, the higher up you go in math, you need to start learning to definitely take a deep breath, and you are going to learn things that you're going to go, I didn't know that was a thing I could do. And that's just part of creativity as you move into math, and you will learn more of when you can, like how to be creative. And then after you learn this like new trick, then you learn to practice it. And then the next time something like that comes up, you become a little more creative. So this patience, practice, and creativity is super, super important. And as a serious skill, I'm quite serious about this, is, staying very consistent. And when something isn't going well, it doesn't mean that you're bad at it. It means that you got to just take a deep breath and figure out, okay, what don't I know? What trick haven't I learned yet? What creative skill did I not know I could use? Take that deep breath, learn that trick, practice that trick, and then move on. Don't beat yourself up over it. So, I've just got to mention that because, like I said, identities were just really hard for me when I took trig. I really beat myself up about them, and I don't want you guys to do that. Okay, so I would recommend you pause the video here, try these. I'm going to just start going through them. Okay. So I'm going to start with sine of x over 1 plus cosine x equals 1 minus cosine x over sine of x. Okay, now you might look at this and say, oh wait, I've seen this before. And so this actually is part of the half angle identity. So these are actually two identities from tangent of a over 2. But this is not sufficient for proving this. So we actually need to go through and show why are these two things equal. And so when in doubt, when you have a fraction, if you're really unsure of kind of how to go about it, I always think just a good first place to start is to try seeing what happens when you multiply by the conjugate. So that's where I'm going to start. So I'm going to multiply by the conjugate of the denominator. And, okay, so let's work this out. So this becomes sine of x minus sine x cosine x. And then in the denominator, I get 1 minus cosine squared x. And now I notice with the 1 minus cosine squared x that is really one of the Pythagorean identities in disguise. So 1 minus cosine squared x, you can get to sine squared x. So we can manipulate that identity to get that. So that's like a very key thing that you want to notice. So this part here equals sine squared x. And I think I need a little more space. Let me clear some space. Okay, so now I have sine x minus sine x cosine x, all of this over sine squared x. And now you'll notice I have a sine term here, here, and here. So every part of this problem has sine in it, which means I'm allowed to cancel. Now, if you get nervous about canceling, I will mention you can always just like become absolutely sure. And I could have just not multiplied out that sine on top. So this is another way to kind of cancel stuff out. So then this will cancel out, and I'm left with 1 minus cosine x over sine x. And sometimes in math, we like to make these little squares, which means that we are done. So I have proved what I needed to prove. Okay, so I've got 1 minus tangent squared x over 2 equals 2 cosine x over 1 plus cosine x. All right, so for this one, lots of different ways I could go with this. I'm going to start with this side here, and I really don't know how to start this. So this is at least a half angle identity, so I think I'm going to go ahead and just bust out one of these half angle identities. Now, the problem that I am looking at, let's see, it all equals a bunch of cosines. So I think I will try using this particular identity here because this identity is just in terms of cosines. I have no idea if this is going to work or not. So if it doesn't work, we'll have to try something else. Okay. So the other thing I'm going to point out is that I'm squaring this so I can get rid of the square root. So this will become 1 minus 1 minus cosine of x over 1 plus cosine of x. All right, so now what? I think next I want to just make a common denominator. So this, I want to rewrite it as 1 plus cosine of x over 1 plus cosine of x. So I'm just going to make that replacement. So let's see. Let me erase all of this so you know my game plan. So this becomes 1 plus cosine of x over 1 plus cosine of x minus 1 minus cosine of x over 1 plus cosine of x. Okay, just be careful when you do this. You need to put parentheses around this. So I want to be super detailed and I don't want to make any mistakes. So I'm just going to rewrite this out like this so that I don't forget to capture that minus sign. And now I can see that the 1s are definitely going to drop out. And this will become plus cosine x. So look at what I'm left with. 2 cosine x over 1 plus cosine x. So woohoo, I did it. Okay, so for C here, I have tangent of a over 2 plus pi over 4 equals secant a plus tangent a. So again, I have no idea how to start this one. I just see that I'm using the tangent of a sum. So what the heck? Let's use the tangent of a sum and let's see what happens. Maybe it works, maybe it doesn't. Okay, so I'm going to write the tangent of a sum. So this will become tangent of a over 2 plus tangent of pi over 4. And then all of this over 1 minus tangent of a over 2 tangent of pi over 4. Okay, so tangent of pi over 4, if we look at the unit circle, that's my favorite. Pi over 4 is my favorite tangent calculation because it's just equal to 1. That's the easy one. So, okay, so I can rewrite this then. This is 1. This is 1. So let's see. This becomes tangent of a over 2 plus 1 over 1 minus tangent of a over 2. All right, so now what? Well, I've simplified this as much as I can, and I don't feel like I'm any closer to getting to this identity. So what I could try now is I could apply the half angle identities. And so now we've just got to be a little strategic here for a moment. So remember, secant, we want to think a little bit about like what's our goal here. So secant of A, remember, is equal to 1 over cosine of A. And then tangent of A is equal to sine over cosine, right? Sine of A over cosine of A. So I bring that up because remembering kind of the denominator of this might help us to choose how we want to go with the next step with this. So if I look at my identities, so I see that I can do sine of A over 1 plus cosine of A, or 1 minus cosine of A over sine of A. So this particular identity has cosine in the denominator. So I'm going to choose this identity next to play around with, okay? So let's see if that gets me anything. So I'm going to just, and again, it just all comes from, I know I need a cosine in the denominator, so I'm letting that kind of drive things. So now I'm going to rewrite tangent of A over 2 as sine of A over 1 plus cosine of A plus 1. And then here I have 1 minus sine of A over 1 plus cosine of A. Okay, so I've written all that out, and now I just notice, you know, general housekeeping, I have fractions within fractions. I don't like that. So I want to clear these fractions. So first let me make some space. Okay, and now let's clear those fractions. So this will be times 1 plus cosine of A and 1 plus cosine of A. And so when I multiply these together, so this fraction times this is going to leave me with sine of A, and then 1 times this will leave me with 1 plus cosine of A. And then in this denominator, 1 times this will leave me 1 plus cosine of A minus, let's see, sine of A. Okay, so, okay, and so now it kind of feels like we're maybe stuck here. And it's like, okay, I don't see anything meaningful. I'm not quite sure how this could possibly get to secant A plus tangent A. And so now what I'm going to show you, like, this is like a straight up ninja level trick. It's not something like I said, sometimes in math, like when you're doing stuff, there are tricks that come out of nowhere that you would have never thought of. And it's like, oh, I didn't know that was something possible. So I'm going to just show you something that I know is a good trick to use sometimes. I am going to try and save this, and I'm just going to see what happens. What if I multiply by cosine of A? So why cosine of A, you ask? Okay, just stay with me for a moment. Let me clear some space. So I'm doing this because I'm specifically interested to see if I can get something that would be useful out of the top. So just go with me here for a second. So I've got, let's see, sine of A cosine of A plus cosine of A plus cosine squared A. And I'm going to leave the bottom alone for a moment. All right, so the reason why I wanted to multiply by cosine of A was I wanted to generate, I wanted to create like one of these squared terms, okay? And I'm not sure, like you could probably also try this with sine squared and you might get like a slightly different path that you'd go down. But okay, so by writing this out as cosine squared A, this gets me this allows me to use another identity, right? So because I've written that out, now I can use my Pythagorean identity, and I can rewrite that cosine squared as 1 minus sine squared. All right, so let's see. This will become 1 minus sine squared A. And so here's where things could get interesting. So let's see. This is my thought. And this is a hard one, by the way. So I've got 1 minus sine squared A. I haven't touched the bottom yet. Cosine A. Okay. All right, so now what? This feels like grouping from factoring. You remember that from algebra? In that, so notice how these two terms both have a cosine in common. Okay, so let's clear some space. And we're just playing around here. Like I said, you need patience. So this becomes sine A plus 1. And then I can factor this, right? This I can technically factor as 1 plus sine A, 1 minus sine A, and oh my god. Have you guys seen what I'm seeing? Maybe, maybe not. All right, so here's the deal. Look at the top. I can group this. This and this are the same thing. I can factor that out. So I'm going to factor out this 1 plus sine A. And what does that leave me with? That leaves me with cosine A. And then it also leaves me with the stuff in here. So cosine A plus 1 minus sine A. Oh my god! It's so exciting when something like this works out. Okay. Why is that good? Now I can cancel this out with this. So very, very clever factoring trick. So again, like I said, sometimes you are going to see tricks happen and you're going to go, I didn't know that was a thing. And then you learn that trick. And then when you're stuck, you just remember tricks like that. That's just kind of how it works. So, okay, I can cancel those out. Cool. All right. Yeah. So now what am I left with? So now I'm here and I'm left with 1 plus sine A over cosine A. Oh my god, this is going to work. All right, so 1 over cosine A plus sine A over cosine A. That equals what we wanted it to equal. Oh yeah, that was a really hard one. So it's very key with these. Like, sometimes you're just going to be in a problem and you're going to go, I don't know what the trick is here. And the idea then is to see what was that creative trick, appreciate that trick, and then remember it for next time. So if you were like, wow, I don't think I could have done that by myself, like it really is just practice. And this does happen sometimes with math classes. You just didn't know it was something you needed to be creative with, so no worries. All right, so I got this crazy looking problem. Sine of 7x plus sine of 5x plus sine of 3x plus sine of x equals 4 sine 4x cosine 2x cosine x. So kind of a crazy identity. So as I think through these, I guess my thought is, like, can I pair these up? Because I know that I have my sum to product identities, right? So by taking like these pairs, I can apply this identity. So I think that's what I want to do here. So I'm going to apply this identity. So we're going to start on the green side. Okay, so that will become 2 sine. So this becomes 7x plus 5x divided by 2 cosine 7x minus 5x divided by 2. So that's this first pair. And then I'll do the second pair. So let's see, that becomes plus 2 sine 3x plus x divided by 2 cosine 3x plus x divided by 2. All right, so let's see. I guess I should simplify all of that. So that becomes 2 sine, what, 12x over 2. 12x over 2 is 6x. And cosine 7x minus 5x, that becomes 2x over 2, so that becomes cosine of x. And then this will be plus 2 sine of 4x divided by 2 will be 2x. And cosine of 4x divided by 2, oops, this should be a minus, right? Yeah, sorry, my bad. This should have been a minus. This will be cosine of x. Okay, did I get it all? Yeah, I think I got the first part of the identity. All right, so now what I notice in these terms, so they both have the cosine x in common. So let's factor that out. So let me clear some space. And then, like I said, I'm gonna factor the cosine out. So this becomes, let's see, why don't we factor out 2 cosine, right? Because they both have the 2 in common. So 2 cosine x sine of 6x plus sine of 2x. Okay, and oh my god, look, I can use the same sum to product again, right? So now I've got sine of a plus sine of b, so I can apply this again. So let's do that. So let's see, this will be 2 cosine x, and now inside the parentheses I'm going to apply that same sum to product. So this becomes 2 sine 6x plus 2x over 2 cosine 6x minus 2x over 2. So that'll simplify to 2 cosine x, 2 sine 4x cosine 2x. Oh, look, we did it. All right, great. We already proved the identity. That was not too bad. All right, let me clear some space just to show you. All right, so now all I've got to do is just multiply all this stuff together. So this becomes 4. Let's see, we'll have this sine 4x come first, cosine 2x, cosine x. So that was actually just a couple applications of the sum to product identity. And this can be kind of the funny thing. Sometimes you're like just working through it and then you're like, oh, I did it. So there we go. Okay, so time for another identity, our last identity. Tangent 4x equals tangent 2x over 2 minus secant squared 2x. This side looks more complicated to me, so I'm going to go ahead and just start with this side, and I'm going to write this side in terms of sine and cosine, because that's kind of our best practice. Okay, so I'm going to write this side in terms of sine and cosine, and then hopefully something jumps out at me. Okay. So I've written this out in terms of sine and cosine, and now I notice that these fractions have the same denominator, and just as a best practices thing, I like to clear my denominators. So I'm going to multiply both of these by cosine squared 2x. So I'm multiplying by cosine squared and not just quote cosine, because if I multiply this part by just cosine, this wouldn't clear the denominator. So cosine squared will clear the denominator for me. So let's see. This will become 2 sine 2x. So on top here, I'm left with one of these. Oops, and this was 2x, not squared x. Okay, so here's this first part, and then in the denominator, I get 2 cosine squared 2x minus 1. Okay. So let's see. You might think that, oh, I see cosine squared 2x minus 1, I can use the Pythagorean identity, but you can't use that here because we have a 2 here. See that? So kind of throws a wrench in things. So now we've got to think for a moment. What else could we try? Do these look like anything? Well, if I go through and I just look through some of my different identities. So hold on, I'm trying to pull them up. Let's see. Maybe I didn't include the... So as I scan through my identities, I see that the 2 sine A cosine A, that looks like the top of what I've got, right? And then the 2 cosine squared 2x minus 1, that's actually this, right? So actually now what I have here is sine of 2a over cosine of 2a. I have to apply these identities in the right way, of course. So let's see. The difference is that these say 2x, so you have to kind of wrap your head around that. So now where I see the a, I'm going to replace them with 2x. So just keep that in mind. So the bottom, or the top will become sine of 2 times 2x, and the bottom will become cosine of 2 times 2x. So let me just write that out while I've said it so I don't forget. so that was sine 2 times 2x over cosine 2 times 2x. Okay, so let me clear a little space. So then these equal sine of 4x over cosine of 4x, and then that is tangent of 4x, which we were trying to prove. Okay, so yeah, identities are, they are really kind of like an art in and of themselves. So you've seen kind of how I have to stumble through them a little bit. So don't be afraid to ask for help if you're getting stuck. Sometimes I think talking these out with other people can be very helpful. If you guys have other ideas for identity videos that you might want to see, feel free to leave me a comment. Otherwise, thanks for watching, guys. I'll catch you next time.